The other part of this first one, basic classes of operation, we'll talk about that one more time. 4 classes of operation you have to know about. The first one is class A. This is for every 360-degree signal in. How would one describe a class A signal? Okay. So we got 360-degree signal, the whole thing. It is the least efficient, and the least, and high fidelity, yes, it is true. Least distorted. And this least distorted means what? I got the whole damn thing, which is high fidelity. Because that's what that means. Fidelity means I got the whole damn signal. There's your class A. Well, that should be pretty simple. Do we know what a 360-degree signal looks like? Do I got to draw it? Okay. Class AB. How do we, actually we'll draw that one just one more time. Describe class AB. Yes. Yeah, it's greater than 180. Whoops. Less than 360. Okay. Meaning that, hey, the output is going to just cross that reference line, because 180 degrees we know from BEO2 is what? Yeah, half of a cycle. So it's going to cross it a little bit, and then it's going to cut off, and then it's going to. So basically, this part of it is clipped, and it'll come back in for the next half cycle as it starts to go in that direction. Positive. Greater than 180, less than 360. So we can say it's more efficient than A. What else? Yeah, it's also more distorted. Because these signals have to do with efficiency, distortion, all these things. And we found that you can use class AB for these 2 circuits right here, push-pull, and complementary of biased transistors for that operation. Because that's what we want. We want the efficiency. What about class B? What does that thing look like? Yeah, easily describe it as, hey, it's just 180 degrees. That's it, it's half a cycle. Done. 180. That should be simple enough. And then class C, what's up with that? Yeah, it's less than 180. Less than 180 degrees. So you got something that's, you know, like that. And the rest of it's going, it's like a little beacon signal. Class B, we already described 180, but it's also more what? Yeah, sure is. More efficient than AB. And of course, it's more distorted. AB, well, and A and AB. Class C, what's cool about that? It's the most power efficient or most efficient. And of course, the most distorted. Anything new about classes of operation? It's all the same stuff. It's all the same stuff, nothing new. The load line itself, where do those classes of operation fall on the load line? If we're more in the center, or we want the full swing, where do we want to be? Yeah, class A. Now we're starting to move down the load line toward cutoff, but not at cutoff. Near cutoff or barely forward bias is what? AB. Class AB. At cutoff is what? B. And then beyond that's class C. So that's where the signals fall on the load line. That's why when we started this one, the push-pull, and I told you the transistor bias for class AB, I had to point this out. Look, it's barely forward biased or barely on, or they're barely conducting because it's more efficient to turn it off real quick, turn it on, conduct off, conduct off, conduct off, or they can switch back and forth. One's on, the other's off. And then the signal gets put back, the other's a class A at the output. So how is the chart and class of operations. Good enough government work?
Yes, sir.
Okay.